So good morning everyone. I am Prajitha Biju, Assistant Professor, Grade 2, Department of Pharmaceutics, Yenepoya Pharmacy College and Research Center. And I am here to teach and give a brief introduction on the module that is suspension. So coming to the contents for today's teaching, it includes the definition, characteristics of ideal suspension, classification of suspension, comparison of flocculated and deflocculated suspension, theory of sedimentation, formulation of suspensions. So the specific learning objective for today's module is, at the end of the class, the student must understand the basic concept of pharmaceutical dosage form such as suspension. So coming to the definition, as we have many pharmaceutical dosage forms, suspension is one of them. So what are suspensions basically? So they are the insoluble solids dissolved in a liquid medium. Why do formulation scientists target to formulate a suspension always? It is when a drug is highly insoluble in the water, and the other important thing is while the drug is very bitter in taste. So while the drug has to be given in the form of an oral dosage form which contains an higher concentration of the drug, that is the solid particles, and it has to be given in a form of an oral formulation, then the only dosage form that is prescribed is the suspension form. And you can see most of the pediatric dosage form will be always in the form of a suspensions. So you can see here this suspension has a particles which will have a size ranging from 100 to 1000 micrometer, which is a little larger in size. So now these suspensions are biphasic system. Why? Because it has the insoluble solids that is dissolved in the liquid medium, and this insoluble solids are always stabilized with the help of a stabilizer or a suspending agent. Now coming to the ideal characteristics of suspensions. A solid particles must be such that it do not settle rapidly. Even if the sediment is formed, it should not form a cake at the bottom of the container. Even if the sedimentation occurs, it must be easily redispersible with a moderate shaking. The viscosity must be such that it can be easily poured from the bottle, and the suspension must be resistant to the microbial attack. As you know, the suspension is prepared only by using the water as a dispersion media. It has a great prone to the microbial attack. So in order to prevent this microbial attack, this suspension is always dispensed in a form of a dry powder, and the reconstituted liquid will be given in a separate container which has to be reconstituted at the time of the consumption. Now the other characteristics includes the suspension for the topical application must be easily spread and form a thin film of medicament at the site of application. Suspension for oral use must be acceptable taste. Coming to the classification of the suspensions. So first, suspension is initially was classified based on the properties of the solids. So the suspension can be classified as dilute or the concentrated suspensions. So now what is dilute suspension? It is the one which contains a very low concentration of the dispersed solid particles in it, wherein in the range of 1 to 2%. The concentrated suspensions are the one which contains the solid particles which is greater than 10%. Now the another classification involves based on the nature and the behavior of the solids. Here the suspension can be classified as a flocculated and the deflocculated suspensions. Comparison of the flocculated or the deflocculated suspension. So this is very important to understand what is flocculated or the deflocculated suspension in order to formulate a suspensions. So what are deflocculated suspension? Here in this suspension, the rate of sedimentation is very slow as the size of the particle is also very small, and the particles will remain as an independent identity, and the sedimentation is closely packed and form a hard cake. So here the particles will be arranged as an independent identity because they are very minute particles, and they will settle in the deflocculated suspension. The particles will settle, but the the settling is very slow, and even and they remain as a closely packed. Once the particles settle at the bottom of the container, there is a chance of forming an hard cake. So once a hard cake is formed, it is very difficult to get redispersion in the deflocculated suspensions. So you can also see that the supernatant layer has the particles get suspended in the sedimented in the deflocculated suspension. You can see that the supernatant layer will become cloudy, but the relative bioavailability of the deflocculated suspension is really high when compared to that of the flocculated suspension. It is because the sedimentation takes a very longer time. Coming to the flocculated suspensions. So here the rate of sedimentation is fast as the size of the floccules formed is large. So the particle settles as a flocks. Now the sedimentation is closely packed and no formation of the hard cake. The sediment is easily redispersed, the supernatant remains clear, and the bioavailability is really less. Here the particles are, since the particles are very larger, there is a formation of the flocks, and these flocks, while the particles come close to each other, they result in the formation of the flocks. Since the flocks have a larger particle size, these have a tendency to come down at the bottom of the container, and they settle and they form a mass there, but this mass is not hard. So what happens is, the moment we shake it, you can see that the particles will be uniformly redispersed, but the thing is, this will get settled at a moment you keep aside for the rest. That is why we say the bioavailability of the flocculated suspension is very less when compared to that of the deflocculated suspension. So theory of sedimentation. So theory of sedimentation of particles are expressed by Stokes law using the formula d square rho 1 minus rho 2 divided by 18 theta. So what is d square? It is the diameter of the particle. Rho 1 is the density of the dispersed particle. Rho 2 is the density of the dispersion medium, and eta is the viscosity of the liquid. Now, the Stokes law is applicable only in the following condition, that is, the particle must be spherical and uniform, and also the particles must settle independently. But in the suspension, the particles are not spherical in size, as well as the density of the particles is the density of the dispersed particle is very high. So in that condition, the Stokes law is not applicable. So the Stokes law basically applies for the deflocculated suspension, and the Stokes law in the qualitative sense, it can be applicable in the three consideration. One is based on the size of the particle, that is, the particle size should be reduced from 1000 micrometer to less, so that the rate of sedimentation of the particle can be decreased. Next, based on the density of the dispersed particles. So usually the density of the dispersed particle, the Stokes law is applicable when the density of the dispersed particle ranges from 0.5 to 1 percent weight by volume, whereas in the suspension the density of the particle is above 10%. So what we have to do is, we have to decrease the density of the dispersed particle by increasing the density of the dispersion medium. You know, the density of the dispersion medium is 1. So we have to optimize, we have to bring it to the equal condition, so that the density does not have an high effect on the rate of sedimentation. Next, coming to the viscosity of the solution. So the viscosity must be maintained in an optimum conditions. So this improving the viscosity has an advantage as well as the disadvantage. So the advantage of improving the viscosity is, it will prevent the settling of the particle, it will inhibit the crystal growth as well as the polymorphism character behavior of a particle. Now, what is the disadvantage of improving the viscosity? While you improve the viscosity, redispersion of the formulation is highly impossible. The rate of absorption of the drug on this rate of absorption can be decreased, as well as the bioavailability of the formulation is decreased. Next, coming to the formulation of suspensions. So now this formulation of suspension is very important. Before we formulate a suspension, we should be first understanding what kind of formulation you want to prepare. It is the flocculated suspension or the deflocculated suspensions. So now you know in the suspension the solid particles are highly insoluble. So now this insoluble particles has to be first wet by using by using a dispersion medium. So now what we do is, since the particles are highly insoluble, we have to use a water miscible solvent in order to improve the wetting, in order to decrease the contact angle between this insoluble solids and the dispersion medium. So while we decreases the contact angle, the interfacial tension or the surface tension between the solid particles and the liquid medium is reduced, thereby it will cause the wetting of the particles. So now the suspensions are usually the insoluble solids that is dissolved in water as a solvent. So now because water is used as a solvent, we will be using a wetting agent as a water miscible solvent. So example to the water miscible solvents are ethanol, acetone, glycerin, etc. So while this is added to the solution, what happens is this glycerin will form a protective layer over the solid particles, and while this is dispersed into the water media, this glycerin will easily go into the solutions. So while the glycerin moves into the solution, the solid particles also get easily wetted in the liquid. So this is the resultant solution what we get, we call it as a deflocculated suspensions. But one of the disadvantage of a deflocculated suspension is there will be a clear supernatant. The supernatant is cloudy because after some time you can see the settling of the particles. So in order to prevent the settling of the particles, we add the structured vehicles. Examples to the structured vehicles are the hydrocolloids. So examples for the hydrocolloids are the non-ionic surfactants or anionic surfactants such as sodium lauryl sulfate, hydroxypropyl methyl cellulose, methyl cellulose, etc. So why is basically the hydrocolloids added? These hydrocolloids in a very small or in a minute concentration can enhance and hydrate the viscosity of the formulations. So now while as the viscosity of the formulation is increased, it can decrease the sedimentation of the solid particles in the suspensions. So that is how we prepare a deflocculated suspension. Next, if you have to convert a deflocculated suspension into a flocculated suspension, then what we do is by the addition of a flocculating agents. To the deflocculated suspension, we add certain flocculating agents, examples like electrolytes, surfactants, polymers, etc. So now you know the dispersed particles in the suspension usually carry the charge on the surface. So because of the presence of the charge, there is a tendency that particles will come close to each other, they aggregate, and the aggregates come down, settle, and results in the cake formation. So in order to prevent that, we add the electrolytes. Now while the electrolytes are added of the opposite charges, this will cause decreasing the charge on the surface of the dispersed particles. Hence because of that, the zeta potential is reduced and the flocculation starts happening. So after the electrolytes, you can also add surfactants or polymers. So now how does the surfactant brings about flocculations? The surfactants has an hydrophilic head and a tail. So it is an hydrophilic tail and an hydrophilic head and an hydrophobic tail. So based on the charge, it gets adhered to the surface of the particles, and the head particles get adhered onto the particle to the dispersed solids, whereas the tail that will be dispersed in the liquid medium, creating a bridge between the particles. And that is how, because of the presence of the bridge, the particles will get close to each other and results in the formation of of a flocculated suspensions. Next is the structured vehicle in the flocculated suspensions. So this is basically done in order to prevent the settling of the particles. So you know this flocculated suspension has a clear supernatant layer, that is because of the rapid settling. So this can be prevented by the addition of the structured vehicle for a flocculated suspension. So the structured vehicle added again is the hydrocolloids in a very low concentration of 0.1 to 1%. So upon the addition of these structured vehicles to the flocculated suspensions, these flocks will remain uniformly dispersed in the suspension and prevents the settling of the particles. So finally, the take home message in the conclusion, I hope you all understand the basic concepts of suspension, the type of suspension, the theory of suspension. Thank you.